Mine.
In the vast ocean of knowledge, mathematics is the compass that guides us, the light that illuminates our way, and the ship that takes us on an endless journey of discoveries. Good morning, ladies and gentlemen. We warmly welcome you all to the auspicious event of National Mathematics Day 2K23. We gather here to celebrate the brilliance, innovation, and the beauty of numbers on the special occasion of National Mathematics Day. It is a day to honor the legacy of brilliant mathematician Srinivas Ramanujan, whose contribution to the world of mathematics continue to inspire us. Today, we pay homage to the legendary mathematician. His birthday on December 22nd is celebrated as National Mathematics Day in India, honoring his immense impact on the field of mathematics. Before we dive into the event, let us remember the word of Srinivasa Ramanujan. An equation for me has no meaning until it expresses a thought of God. Following his path, let's first take a moment to pay homage to the divine forces that guides us. I kindly request respected dignitaries on the dais to come forward and lead us in the lamp lighting and garlanding the photos of Rajasanta Tukadoji Maharaj and Srinivas Ramanujan sir. Perform this ritual as an inspiration from the spiritual energy that has guided scholars and Sikhs throughout histories, honoring the divine connection between the knowledge and spirituality. Ladies and gentlemen, as we continue to immerse ourselves in the celebration of National Mathematics Day, it is time to bring forth a movement of unity and pride. Just as a number forms the basic of mathematical equations, our shared experiences and aspirations are the foundation of our academic community. Before moving forward, let us together honor our institution by singing University's song, which stands as a symbol of collective journey, the pursuit of knowledge and the spirit of brotherhood that unites us all.
Devarchi asade,
Srinivas Ramanujan, a mathematical genius born in 1887 in India, displayed an extraordinary affinity for numbers from a young age. Despite facing significant challenges, his self-taught journey led to a groundbreaking contribution in number theory, infinite series, and the mathematical analysis discovered by G.H. Hardy. Ramanujan's collaboration with the British mathematician produced profound results that continue to shape the field. His unparalleled insights into the mathematical patterns and relationships, coupled with an unyielding passion for discoveries, have left an indelible mark. Ramanujan's legacy serves as an enduring source of an inspiration, reflecting the limitless potential of human mind. Ramanujan's tragically short life ended in 1920, leaving behind a legacy of unparalleled mathematical genius that continue to inspire and shape the world of mathematics. Now, as we dive deeper into the heart of our National Mathematics Day celebration, it's time to shine the spotlight on the special guest who will be taking on an exciting journey through the fascinating world of numbers and equation. I request respected Dr. G.D. Kedar sir to welcome Honorable Dr. Subhash Chaudhary sir, Vice Chancellor of Rashtrasanta Tukdoji Maharaj, Nagpur University, Nagpur, with token of love, symbolizing gratitude and admiration. Also, I again request respected Dr. G.D. Kedar sir to welcome Honorable Dr. Rajesh Singh sir, Director, Innovation, Incubation and Linkages, Rashtrasanta Tukdoji Maharaj, Nagpur University, Nagpur, with token of love. I again request respected Dr. G.D. Kedar sir to welcome Dr. Divakar Shukla sir with token of love. I request Mr. Nikhil Jaipurkar sir to welcome respected Dr. G.D. Kedar sir, Professor and Head of Department of Mathematics, Rashtrasanta Tukdoji Maharaj, Nagpur University, Nagpur. I would also like to welcome all teachers, teaching and non-teaching staff, the wonderful blend of wisdom, enthusiasm and encouragement, and the students, the future mathematicians and all cherished audiences. I welcome you all. Now, let's keep the spirit of curiosity alive as we continue to explore the vast landscape of mathematics in upcoming segment of our program. I request respected Dr. G.D. Kedar sir, Professor and Head of Department of Mathematics, RTM Nagpur, to guide us in the upcoming event of National Mathematics Day celebration.
So, good morning all of you. Can you hear me properly? आवाज आ रही है? जोर से बोलना पड़ेगा. Okay. So, at the outset, I pay my homage to Rashtrasanta Tukdoji Maharaj and a great mathematician, Srinivasa Ramanujan. As you all know, we are gathered over here to celebrate the birth anniversary of Srinivasa Ramanujan. And under this celebration, we have here 3-day program. First, on this day, we have organized a workshop on mathematical modeling. Tomorrow, we will have 2 competitions, quiz competition and seminar competition. And on 3rd day, we will have some popular talks over here. President of today's inaugural function, Honorable Vice Chancellor, Dr. Subhash Chaudhary sir. Today's guest of honor, Honorable Dr. Rajesh Singh sir, Director, Incubation, Innovation Linkages. Speaker of today's workshop, Honorable Dr. Divakar Shukla. He is from BHSC Vishwavidyalaya Sagar, Madhya Pradesh. All the faculty members from the affiliated colleges, my colleagues, and all participant students from other colleges and the students from this department. Why the mathematical modeling? Because as we have a core knowledge of mathematics, because from last 16 to 17 years, we are learning mathematics at different levels. But the core knowledge of mathematics may be not useful if we are not using that in practice. Because mathematical modeling is a light mathematics rather. Because when we study in the core mathematics, obviously that is a beautiful thing, but the light mathematics can be used in your daily life so that you can solve many more problems by using mathematics. Because mathematics is one of the powerful tools to predict many more things. And by predictions, we can avoid the experimental practices. Without taking any kind of experiment practice, we can have the desired results. And after that, by changing the parameters, you can easily find out the ways in the practical problems also. So that's why we are organizing here the workshop on mathematical modeling. As we know, in 1918, Harvard University and Stanford Research Center done a research, and in that research they found that the 85% of job success comes from the soft skills, or you can say that as a people's skill, while only the 15% job success come from the core skills. But after the 100 or more than 100 years also, most of the institutions are giving the formal education in the form of core topics. Why it's so? Because in fact the soft skills cannot be taught to anyone. That to be developed by yourself. Someone can guide you to develop that. Someone can help you to achieve the goals in that. But that to be achieved by yourself only. Because core mathematics you can find the much more resources for that. You can learn that from teacher, from the books you can read it. You can go through the different kind of literature from which you can find it. And the core knowledge is also measurable. We are giving the different kind of examinations for that, and you can find out how much knowledge you have achieved and how much you have to tell to go for that. But soft skills, we don't have a kind of measurements, but it has a resultant always. Because if you see, if we take the example of doctor, when doctor goes to the patient, obviously due to his core knowledge, he can find out the disease or any kind of illness to the patient by taking different kind of test or the symptoms, he can find out it. But when he deals with the patient at that time, आप मुझे लगता है कि अभी भी आप मुन्ना भाई MBBS की पैर की झपकी जो है झप्पी, वो आप भूले नहीं होंगे। तो वो पैर की झप्पी जो होती है, दैट इज एक्चुअली द सॉफ्ट स्किल। किसी को अगर आपको हील करना है तो ऑब्वियसली आप उसको दवाई दे सकते हैं, पर अगर आपने उसके साथ सॉफ्ट स्किल यूज़ किया तो हो सकता है कि उस दवाई का असर डबल हो जाए। आप कहेंगे कि सॉफ्ट स्किल से ऐसे क्या होता है, मतलब फिजिकली कैसे उसका इफेक्ट हो सकता है। आप जानते हैं कि जब युद्ध में जाते हैं तो एक सेना नायक लोगों को अपनी जान देने के लिए तैयार करता है। एक ताकत उसके शब्दों की ही होती है। सो सॉफ्ट स्किल इज मोर पावरफुल than that of the hard skills there. But even though hard skills cannot be ignored, obviously, क्योंकि वो कहते हैं ना कि अगर कुएं में घी नहीं होगा तो फिर वो बकेट में कैसे आएगा, तो कुएं में पानी होना जरूरी है, then you can use the tools to bring out it. So ये बहुत necessary है, and taking all these in considerations, we have taken this event with the mixed bag. Today we are having a workshop. After that, you have an opportunity to show or showcase your skills in the competitions, quiz competition and seminar competition is there. And after that we have the popular talks on the occasion of this National Mathematics Day. So I must express the thanks to two particular bodies. First, that is the body of DST, which is National Council for Science and Technology Commission, Government of India, and Rajiv Gandhi Science and Technology Commission, Government of Maharashtra. They gave the financial aid to this celebration of National Mathematics Day. Every year they used to give the such kind of aids. This time, but they curtail little bit funds, and it was not possible to organize all these events without the funds. So, as usual, our parent university come with the helping hand, and they sanction very big amount of financial aid to this event. So I am also very much thankful to the authority of Nagpur University to provide the financial aid to this function. At last, I request all you to take the advantage of all these events, and I hope this program will be proven very beneficial to all of you. Thank you, one and all. Thank you.
Thank you, sir. Your words have added another layer of richness to a celebration of National Mathematics Day. We are honored to have Honorable Dr. Rajesh Singh sir as a distinguished personality and a true supporter of education. I request Honorable Dr. Rajesh Singh sir to say a few words and grace this occasion.
Very good afternoon. President of this inaugural program, Honorable Vice Chancellor, our invited speaker, Dr. Diwakar Shukla, Head of the Department, Dr. Kedar, invited teachers of affiliated colleges, and my dear student friends. Today I am very glad to be here on the very great occasion of celebrating National Mathematics Day 2023. In fact, this day was on 22nd December, but due to some difficulties, you can say unavoidable circumstances, we are celebrating today. So at the outset, I give my best wishes to you all on this day. As you know that this day was started in 2012 by Honorable the then Prime Minister Dr. Manmohan Singh ji, and the aim of starting this day, National Mathematics Day, was to promote the mathematics in our students, because from the last several decades we are seeing that this subject is not the preference of students. Sometimes students think that this is a boring subject, nearest, non-applied, and therefore students were going for subjects like physics, chemistry and engineering. That was the reason government decided again bring back to our students in the subject which is, someone say that some father of all subjects, mother of all subjects. Mathematics कोई mother of all subjects बोलता है और कहीं कहीं father of. But this is the basic subjects. जब से if a human, you can say, start the thinking, that from that time this subject is started, mathematics is starting from the numbers. So to bring back again the student, this day was started, and every time we keep some theme, and then we promote our students in that particular area. Somewhere I read that one of the very noble laureate person written, I was reading his biography, then he said that he was loving the mathematics subject as a student, but because physics was more applied, therefore he selected the physics and left the mathematics as a subject for master degree. So this subject has again gained the applied area. Now you can see that mathematics is being used as a model for all the subject. Biomathematics is one of the area. And other where in the all analysis type of work, this mathematics subject is being now used. And therefore, this title of the today's workshop, or means activity which will be held today's workshop, that means mathematical modeling, is a very, very relevant topic for this workshop. Here you will learn how to do the model, how to develop a model for a particular problem. The simple thing, y is equal to mx plus c, it is a model which everywhere you people use. So in this way, model will be developed for the applied region. Modeling concept, your speakers or resource person will tell you. Basically, from real problem, you have to develop a mathematical function. Convert real problem into the mathematical problem. And again come back from mathematical problem to solving the society's problem. You have to take the real data and develop a mathematical problem, and then for society problem you have to use that developed model and give the solutions. That is the basic aim of this modeling. For example, you see forecasting of the weather forecasting. What is that? That is a simple modeling using the different type of parameter constants, pressure, temperature of few days and other parameters, and they predict when the rain will be occurring in this particular region. And that is done by using the mathematical model. And that has been developed by purely mathematicians. Many problems or many things you may not imagine which are being used in our day-to-day life, real life, that has been developed by mathematicians, not by the scientists of that particular area. I am missing some great examples, but if you are reading Times of India, many times you will find that the model, in the case of COVID prediction, mathematicians given the model what will be the number in the coming months. Number of cases will be this much, that much. Who gave that? That was the mathematician given by Kanpur IIT professors of mathematics. So that type of mathematical modeling are being done for prediction, and whatever is at present being done, that may not be the final model. There is still a lot of scope that you can improve that model by adding some additional features, some additional parameters, some additional variation. Probably you may get better result than what present model is giving. You may be seeing the image of what we say rain image आता है geo mapping somewhere hill and somewhere red dark, somewhere sea color blue, ऐसा geo mapping satellite mapping से आती है image ना. We are thinking that is the correct, but one of the paper I read in the JASA journal that still there is some error. जितना area दिखा रहा है शायद उससे ज़्यादा भी है. And he proposed a new model and claimed that this is more accurate result than the present one. So what we are seeing, that is not the final. There may be some error that you have to search and establish new model. In the genetical science, one of my MPhil student did the modeling of gene data analysis. That was Bayesian analysis in applied statistics. That was MPhil. But that lady developed a model for genetics type of data. And last year only one of my students has awarded PhD in the TB tuberculosis data modeling. उसमें उसने जो एक होता है सर non-curable TB. For that she has developed a mathematical model and she has been awarded. So mathematical model has become applied in every area of the real life problem, and you can develop a model and you can apply for solving the problem of the society. And due to this, the application of mathematics has increased a lot. The earlier days has changed now. This subject has become more applied and the students are getting more interest, more loving this subject than earlier. Earlier only mathematical solving the problem was there. Now due to software ready-made packages, computer, AI, you can do a lot. You can change the world, you can solve all the problems, many problems of the society. You have to think where you can apply. And कोई लिमिट नहीं है, मॉडल्स बनाने की कोई लिमिट नहीं है. ओनली थिंग है you have to think that how your model will be simple, how realistic and how accurate. In point you have to notice. Simplicity also, because if it will be very complicated, then probably it will be a limit for its application. And accuracy is the ultimate thing. That without accuracy, wrong model if you will propose, then nobody will accept. So that gives a new dimension to mathematical research area, and all the new coming generation, young generation can take as a challenge and do their mathematical model. इसमें फिगर्स भी आता है, ग्राफ आते हैं, फिगर. तो आजकल बड़ा व्हाट्सएप हम भी यूज कर लेते हैं, थोड़ा सा आता है ना. व्हाट्सएप में एक मेमे आता है बोलते हैं, तो उस पर लिख के दिया था, किसी फॉर्म में था फन के ही, कि आई लव मैथमेटिक्स बिकॉज इट हैज ए लॉट ऑफ मॉडल्स with beautiful figures compared to Bollywood and Hollywood. हालांकि फैक्ट ही था, मैथमेटिक्स में इतने तरह के फिगर्स आप जनरेट कर सकते हैं मॉडल से कि बियॉन्ड इस इमेजिनेशन. जब नया नया ये मैटलैब आया था तो हम लोग उसके ग्राफिक्स को बहुत इंजॉय करते थे। 3 डायमेंशन में अपने रिसर्च प्रॉब्लम से हर डायमेंशन से रोटेट कर करके देखते थे, फिर उसका प्रिंट क्या सबमिट करना वो सिलेक्ट करने में बहुत मजा, कलर भी आता था। इट वाज ए न्यू थिंग फॉर अस। जो ग्राफर सॉफ्टवेयर पहले हम लोग यूज करते थे ग्राफिक्स के लिए, ग्राफर तो 2 डायमेंशनल केवल देता था, और मैटलैब वाज ए मीन सरप्राइज या बियॉन्ड इमेजिनेशन हमारे लिए था कि वाह क्या आ रहा है। सो सच टाइप ऑफ फिगर्स यू कैन जनरेट फ्रॉम योर मैथमेटिकल मॉडल। I hope this workshop will give means real knowledge to you in mathematical modeling. It will be fruitful to you all. You will really learn some new things about mathematical modeling, and I hope this will be a very successful event for your future career. I will stop here, but only one thing add. बहुत बार देखते हैं कि एक कंपटीशन हुआ था मैथमेटिक्स का इक्वेशन लिखने के लिए। यू हैव टू राइट ए इक्वेशन दैट शुड बी वेरी सिंपल। बहुतों ने बहुत से E=mc² लिखा, किसी ने Y=mx+c लिखा। सिंपल होना चाहिए और अट्रैक्टिव होना चाहिए, जो इमीडिएट क्लिक करे। फर्स्ट प्राइज भी था उसको, और ये यूएस में कंपटीशन हुआ। कैन यू गेस विच इक्वेशन वन द फर्स्ट प्राइज? सारे इक्वेशन लिखने के बाद फर्स्ट प्राइज किस इक्वेशन को मिला? 1 + 1 = 2। द सिंपलेस्ट वन एंड मोस्ट ब्यूटीफुल वन। थैंक यू वेरी मच।
Thank you, sir, for your valuable experience and constant support. We are privileged to have you with us today. We are honored to have another distinguished personality with us, Dr. Diwakar Shukla. Dr. Diwakar Shukla, sir, DHS Gaur Vishwavidyalay, Sagar, Madhya Pradesh. World of mathematics has not only shaped their own journey but has also left a memorable mark on the broader mathematical community. I request Honorable Dr. Subhash Chaudhary, sir, to enlighten us with his words.
With the great homage to Vandaniya Rashtra Sant Tukadoji Maharaj and great mathematician Dr. Ramanuj, I first of all regret to say that I was late to come here for this program, because today I was having 3 different inaugurations. Out of those, this is second one. And now, just at 1 p.m., I have very important meeting of Management Council. So that's why I seek permission to get free myself as early as possible. So this is again the program which was expected to be on 22nd December. But due to some technical reason, due to some other reasons, the program has been designed and placed during these 3 days. So dignitaries on the dais, Dr. Diwakar Shukla ji, then Dr. Rajesh Singh ji, and Dr. Kedar sir, and faculty members and dear students. The topic of this workshop is mathematical modeling. And modeling means not the model of any shape or structure and all. For mathematics, it is the expression or formula. The complete universe runs under with some mathematical model. complete universe. Either you know mathematics or not, it is continuing since long. मैथमेटिक्स जब से समझा उसके पहले से मैथमेटिकल एक्सप्रेशन और मैथमेटिकल मॉडलिंग पे पूरा यूनिवर्स चल रहा है. ऐसा नथिंग इज देयर विदाउट एनी इक्वेशन, विदाउट एनी रिलेशन, विदाउट एनी perfect calculation, the things are going on. Still today, the planets and all those are moving around the sun with its orbit. And we always say about Newton's law and everything, law of conservation of energy, law of conservation of mass, everything. Energy cannot be converted into, energy cannot be created nor be destroyed. And nothing moves without energy. Then why these planets are moving around? Who is providing the energy? There may be something, and some mathematical expression is working, and perfectly it is moving around this. एक भी डिग्री इधर उधर नहीं होगा. Even if you calculate today, after where would be the Pluto or Neptune or any Saturn, any planet in the space, you can calculate now also. So perfection is there, mathematics is there. हमारा बॉडी भी प्रोपोर्शनेट बढ़ता है, ऐसा नहीं एक हाथ बड़ा हो गया और एक छोटा हो गया. So this is because the complete structure is growing, everything is growing, either plant, human being, animals, complete thing is going with mathematical modeling. No doubt we don't know that expression, what is the formula, but it is going. I had one discussion with one of the scientists, that is Dr. R.T. Zadov. He was the professor in chemistry. One day I visited his office, and he was working with some calculation. I said, what are you doing? So he said some name of one scientist and said, this number I am searching. And I said, for what? He said, नहीं, पूरा जो चल रहा है ना वो एक expression पे चल रहा है. One expression. He was searching on that. Even the flowers के जो petals हैं, that circle, that motion, that everything is that proportionate. That is the proportion. हाँ, ऐसा sequence. वो तो हम अभी खोज रहे हैं, लेकिन वो पहले से है. जब भी whenever you go for any research, and if you are in position to prepare the final expression of your research, then that is your perfect research. Mathematics is perfect. सर ने बहुत अच्छा कहा, 1+1 2 ही होगा. 1+1 11 करने वाले बहुत हैं, 1+1 5 करने वाले बहुत हैं, 0 करने वाले भी बहुत हैं. But 1+1 2 ही होगा. It cannot be 2.1 or 1.9. No, 1+1 is equal to 2. So that is the perfection. If you convert your research into an expression which we call it as model, then nothing is required to validate your research. I also undertook one research, that is the cement, invention of new cement without using our factory cement. And I took the different proportion and all that. There were many results and test reports. I integrated that and prepared one mathematical model. And once you prepare one expression, it becomes permanent for all. अगर वो आपने अपने thesis में last में अगर बोल दिया कि after all these I have prepared this mathematical model for complete research, then that is excellent. No one will challenge. क्योंकि mathematics itself is the proven concept. इसीलिए चाहे किसी भी लैंग्वेज में हो, अगर आपके पास मैथमेटिकल एक्सप्रेशन बन जाता है तो फिर कोई दिक्कत नहीं. इवन कंप्यूटर्स जो चल रहे हैं, ऑल कंप्यूटर्स, वो लैंग्वेज नहीं जानता, ABCD नहीं जानता. उसको लॉजिक 0 और लॉजिक 1 इतना ही मालूम है. उसके बाहर कंप्यूटर डजंट नो एनीथिंग. Machine language is different than our programming language, and that is totally based on the numbers. And that's why numbers are very much important, and those numbers can be played with the mathematical expression. And वो तो स्वाभाविक है. If you are perfect, your expression is perfect, you will get perfect result. अब आप में से बहुत लोग खाना बनाते होंगे, एक आध दिन सब्जी अच्छी बन जाती है, लेकिन बाद में वही चीज़ हम लेते हैं, लेकिन थोड़ा सा गड़बड़ होती है. अगर आपने बहुत थोड़ा सा समय दिया और उसके प्रोपोर्शन बनाया, इतना % मिर्ची, इतना % हल्दी, इतना % प्याज, इतना % ये, और आपने ट्रायल ले लिया और एक एक्सप्रेशन में आपका खाना अच्छा बन गया, तो वो परसेंटेज आ गया. नाउ दिस इज %. अब किसी को भी दे दो, बस ये अच्छा बन जाएगा. लेकिन वो एक्सप्रेशन पूरा है क्या? आपके लिए वो ठीक था, जो मटेरियल आपके पास था उसके लिए ठीक था. आपने कहा कि 0.1% मिर्ची लिया, लेकिन किसी के पास फीकी मिर्ची होगी, किसी के पास तीखी मिर्ची होगी, उसका क्या करेंगे? देन अगेन यू विल हैव टू गो फॉर डिटेल पैरामीटर्स. तो आइडेंटिफिकेशन ऑफ पैरामीटर्स इज मोस्ट इम्पॉर्टेंट टू गेट द परफेक्ट मॉडल, मैथमेटिकल मॉडल. उसमें और कौन से सब पैरामीटर्स होते हैं, उसको भी आपको खोजना पड़ेगा, तब जाके वो परफेक्ट आएगा. अभी किसी ने कहा है कि वेदर रिपोर्ट अपने इंडिया में या कहीं पर भी क्यों फेल होता बार बार. बाद में ध्यान में आता कि अपने ये पैरामीटर छूट गया, समवेयर दिस इज मिसिंग, देन दे ऐड इन द एक्सप्रेशन कि ये पैरामीटर है. So identification of parameter is the greatest challenge, and that everyone has to do. Preparing the expression, that means preparing the mathematical model, is the real work. And how to prepare that? What are the different techniques? What is the basic of formulation for the mathematical expression? To create something new expression. दुनिया भर के expression होंगे, दुनिया भर के formula होंगे, आपको अपना फॉर्मूला बनाना है. And that is through your research work, through your data, and through all your activities. And how to do it is more important. And that's why this workshop has some meaning. It will give you insight how to prepare, how to move for the mathematical model, and how to arrive at final conclusion and result. I hope this workshop would be most beneficial for your this curriculum, as well as in your future also. With this, I conclude here. Thank you very much.
We are honored to have another distinguished personality, Dr. Divakar Shukla sir, DHS Gaur Vishwavidyalaya Sagar, Madhya Pradesh. I request you, sir, to please come forward and say few words to grace this occasion.
Good afternoon to all. Head of the department, Professor Ganesh Kedarji, Vice Chancellor of the University, Dr. Subhash Chaudhary ji, Professor Rajesh Singh, all students, faculty members, faculty of colleges, they are here. It is my privilege to be here in this university after a year. Last time when Indian Science Congress was held here, I was one of the delegates who was sitting in this hall, and repeatedly, just after 1 year, in the first week of January, I again here. So it is a cyclic fluctuation of the event one can think of, and I hope in 2025 I may again come here. This is my prediction based on single unit observation. If I get the data from last 6 or 7 years, then we can predict in much better way that in 2025 January, or maybe with some error first week of February, I must be here again, maybe celebrating the occasion of any of the eminent person, maybe a mathematician, maybe statistician, maybe chemist, or there may be some event of the conference organized by the head of the department. This is my prediction. So behind this prediction, there is a valid data, and on the basis of the valid data, I used cyclic occurrence of the event. I made this event cyclic, and I assume that it is happening every year, so it will happen in 2025 also. And this is the model based on single data, based on 5 or 6 year data. Also, lots have been told about the Professor Dr. Ramanujan. I also have few words for him, that in a very short span of his life, maybe 32 years in total, he has done a lot of mathematics towards the development of the theorems, conjectures, and some proved results, some unproved results, and the short duration, his contribution to mathematics was outstanding. This is the spark which needs to be generated among youngsters, among students, among the faculties, so that we can have the lightening of mathematics among those who are afraid of mathematics. When I was a student in Banaras Hindu University, in research scholar, as a research scholar, I visited the history department, and one of the research scholar of history asked me, in which subject you are doing the research? I told mathematics. There was surprise. Why the scholar? मैथमेटिक्स में PhD होती है क्या? In history it is okay, in sociology it is okay, it's a routine matter, but what about mathematics? And when I was student in class 10th, my teacher was PhD in mathematics, and he was teaching the mathematics. When he used to leave the class, we students discuss. I remember a few of the words of my friend who was at 10th level with me, sitting near by me. He told that, sir has PhD in mathematics, कुछ तो नया किया होगा. कुछ तो नया किया होगा. And I am unable to understand the mathematics of 10th class, facing difficulty in deriving the expression, deriving the Pythagoras theorem, which was in 10th class. What is the level of my sir who is teaching me his PhD in mathematics? This is the case. And one person has created a joke on mathematics, which was a social joke. किसी ने कहा, दूल्हे जी मैथमेटिक्स में PhD, तो लोग थोड़ी पकड़ के देख रहे थे, आखिर मैथमेटिशियन होता कैसा है? Because mathematician is a distinguished feature of the society. Mathematician is a person whose face has some glory of mathematics, because mathematics improves concentration, and vice versa. If you want to improve your concentration, do mathematics. This is what the glory of mathematics. And if you are involved in mathematics, solving various problems, solving various expression, deriving something new, and if you have the uh, flavor of mathematics, then definitely your face will be enlightened in some other way, and anyone in society will say you are padhe likhe aadmi. That is the glory of the face, and it comes from the immense level of concentration that has been developed by solving a variety of problems. That is the impact of mathematics over the personality. So, why this is being celebrated? The occasion of birthday of Dr. Ramanujan. He was not PhD, but he has done the outstanding contribution to the various theories, but in particular the number theory. At the school level, if there are 500 students in class 1, many of them are afraid of mathematics. In class 2, some leaves. In class 3, also the afraid remains same. When they change their subject at 10th level or 8th level, they want to leave mathematics and join biology. Biology has a very immense craze. But career in biology and career in mathematics both have different impact in society. And also, if you attend a marriage ceremony of a professor in the university, you will find very few mathematicians having the dinner with others. Try to find out this fact, that in this reception ceremony in the university or in nearby your friend circle, very few will be having MSc mathematics, and the rarest of the rare will be PhD in mathematics. So see, and you will find many who are having MA sociology, many who are having MA history, and so on. But rare will be having mathematics degree. So why this rare? Because there are two tough subjects, one in science side, that is mathematics, and Sanskrit in arts and social science. Other subjects have relatively less difficulty level. So this program of enjoying, celebrating the National Mathematics Day is basically to create a spark among children, to create a spark among graduates, to create a spark among postgraduates, to select the subject mathematics as their career. And nowadays, when the data science has emerged, then there is an important role of mathematician for data sciences, important role of statistician for data sciences, and also the role of computer sciences in data science. So if you have some knowledge of software handling, computational ability, along with mathematics, certainly at the level of scope of the job in area like Bangalore or cities like IT-based cities, you will get the job easily. So with these few words, I feel privileged of the head of the Department of Mathematics for inviting me here, and also the anchor of this program who are sitting on my left. Just ask, would you like to have few words? Yes, I say, I agreed upon to deliver few words, and thereafter there will be my lecture. I will discuss some of the simple way of understanding the model, and also their creation, application, and so on. So thank you very much for all those who are here on the ground. Thank you.
Thank you so much, sir. We are privileged to have you with us today. The world of mathematics has not only shaped, Today, on this auspicious day, we are here to break the misconception that mathematics is only about numbers and equations. It is an integral part of our daily lives, from the pattern in the nature to algorithm that powers the digital world. Now, I welcome Divya Durkar for formal vote of thanks.
Good afternoon to one and all present here. I, Divya Durkar, student of MSc second year, Department of Mathematics, RTMNU, Nagpur. It is my pleasure to give vote of thanks on behalf of Department of Mathematics, RTM, Nagpur University. I am really thankful to the Honorable Vice Chancellor of RTM Nagpur University, Dr. Subhash Chaudhary sir, for their valuable guidance, precious time and great wishes for this program. Thank you, sir. I am also thankful to the guest of honor, Honorable Dr. Rajesh Singh sir, Director of RTM Nagpur University, for their valuable words for students. Thank you, sir. Also, I am thankful to the guest of honor, Honorable Dr. Divakar Shukla sir, for their valuable presence and enthusiastic guidance. Thank you, sir. I am thankful to the coordinator of this 3 days event and our precious mentor, respected Dr. G.D. Kedar sir, for their valuable presence and support. Thank you, sir. I am also thankful to the teachers and research scholars for their support and presence for this event. I extend my heartfelt gratitude on behalf of the organizing committee for National Mathematics Day. To all the students, presence and enthusiasm have contributed to the success of this event, celebrating the beauty and importance of mathematics. Special thanks to our speakers, sponsors, and everyone involved in the making this day memorable. Let's continue to appreciate and promote the significance of mathematics in our lives. Thank you. On behalf of the president of this program, I declare that inauguration program is ended by national anthem. Please stand up for national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Guest speaker, whose passion for maths knows no bounds. Dr. Divakar Shukla sir, Senior Professor, Department of Mathematics and Statistics, Dr. Hari Singh Gaur, Vishwavidyalay, Sagar, Madhya Pradesh. His expertise in sampling theory, Markow's chain, computer networking, computer operating system, big data, inventory modeling, and many more. He is currently working as Senior Professor in Department of Mathematics and Statistics in Sagar, Madhya Pradesh since 2018. He was a research scholar in BHU and hold CSIR fellowship. He served Devi Ahilya University, Indore as assistant professor for 8 years. Then he joined Sagar University as associate professor. He also served in Lucknow University, Lucknow. He visited abroad to Australia and China for invited lectures and conferences. He was head of Department of Computer Science for 7 years, in charge of library for 7 years, and in charge of IT cell for 7 years. He was awarded with UG UGC Career Award by UGC Delhi, ISAS Young Scientist Medal by ISAS Young Society New Delhi, MPCUST Young Scientist Award by MPCUST Bhopal with 180 journal articles, 8 book chapters, 7 books, 76 citations, total 180 publications, out of which 153 research articles, 12 book chapters, 18 conference proceedings, 23 PhD awards, and many more. He excelled in his life with great achievements. I heartily welcome you, sir. I request Honorable Dr. Divakar Shukla, sir, to guide us on basic of systems, modeling and simulations.
Thank you very much for anchor of this session, for inviting me here for the lecture, and also reading my biodata. These figures in biodata is basically the consistent contribution in academics right from the beginning, right from the research scholar stage to today. And when you will travel the same path, that is your career as a faculty member, and you will contribute every day, then ultimately when you come to the age of 60, you will also attain this level. Okay. I have been asked to talk about the modeling, and my target population over here is students of MSc, students of colleges, faculty of colleges, or maybe some interested person. So I have made my presentation lighter. Why lighter? Because it may very well acceptable, very well understandable to the audience. My target, my preparation of the lecture is as per assumed target audience. Okay, so this entire topic of the talk, that is system, modeling and simulation. We have the system. Who comes first? It is the system comes first. We were having lots of discussion in the inaugural session about the modeling, but we have left the basic, which is the system. System come first. Understanding of the system come first. Then start the modeling, and then at the last stage performs the analysis, which is preferably the simulation. So first stage is the system, second stage is the modeling, and third stage is the simulation. What is a system? What is a system? We have so many systems. Everywhere there is a system. You say there are rules, regulation in university. University itself is a system, and the collection of interrelated variables of the affecting forces, and also the various components working together. That constitutes a system. So you are organizing a kind of workshop. So there is a system. What system is that? Inaugural will come first, and conclusion will come at the end. Can you reverse these two? You cannot reverse. It will be better if you take concluding ceremony first, and inaugural at the last. This is not possible. And then followed by the events during this activity. And events are those who are planned, and activities are those where the energy is consumed. The whole occasion is divided into events and activities. Occasion is a big planning. Say for example marriage. Marriage is an occasion. And in a marriage there is a events like haldi, like chuna, like some others, maybe face off, maybe face on, maybe dance, maybe photo sessions, and lots of events. And for every event, there is a energy consumption, and also the consumption of the money, So, occasion, this is an occasion, and occasion is being divided into events, and events has several activities, and then ultimately the whole marriage that is being occurred or likely to occur is a marriage system. What if I want to study a marriage system? There are lots of problems. Marriage system of what? It is time dependent, it is caste dependent, it is religion dependent. So every marriage system is of variations. Then what to study? There are a number of parameters that we have to study a marriage system. That is, what is the time between engagement and occurrence of the event marriage? Okay, what is the time duration? It's very difficult to predict. What is the average time of a rural area? What is the average time of the city area? What is the average time of a particular caste? What is the average time of a particular religion between engagement and marriage? In Hindi it is called Chat Mangni Pat Vyah. What is the difference of time between Chat and Pat? Unpredictable. But whole marriage is a system. It is the unpredictable. If it is there, then if we collect the data of 1,000 marriages of a particular community, of a particular duration, we have some insight. Insight means some knowledge. And some knowledge is there, then we can form the knowledge, we can convert the knowledge into rules, and rules into laws. Knowledge into rules, and rules into laws. And the word hypothesis appear. Hypothesis means something which we assume, but it is not proved. Something is assumed, but it is not proved. Say, for example, sir is sitting here. I have a hypothesis for him that whenever activities occur, he sits on the front seat. This is my hypothesis. But it is not approved. It is unproved. If there are 10 or 20 occasions, photographs are there, and I always find sir sitting in the first seat, my hypothesis will be proved. And when it is proved, it will be a rule. It will be the theorem. It will be the rule. And if there are n number of rules, then we can have a law. A law is a set of rules. And every rule has a proof of the hypothesis. Hypothesis is an assumed fact. It is not the believed fact, but it's assumed fact. So we have ultimately, when we come across the system, we have the system there is a system we want to achieve a goal. Say, for example, a digestive system. Our body has a digestive system, and we want to improve our digestive system. Why? The goal is that whatever I eat, it will be digested. I can eat whatever I want, and the amount whatever I want, and the time whenever I want, and also the as maximum as possible. And if I am going to a marriage ceremony in evening, night, I can hold maximum number of rotis, maximum number of sabjis, and starting menu from soup to ice cream. The journey of a party starts from soup and ends at ice cream. The maximum crowd is at ice cream. Okay, so this entire thing happens only if if we have a very good digestive system. And if there is a system, then it needs to be studied. It needs to be studied. And goal is to optimize the system, to keep our system best so that whatever I eat, it is digested. So there is a problem-solving approach that is for system, and problem-solving approach for the for an equation. If you have the equation, then problem-solving approach only solve that equation. But if you have a system, then problem-solving approach that needs lots of imagination. Say, for example, there may election in Maharashtra, and a party A wins the election, assembly election in Maharashtra, and after election what happens? Everybody wants to become CM. Everybody wants to become CM, but there is one vacancy for CM. Now, who will be the CM? This is the problem. If I say, suppose I am the boss of that party, I will select. My non-system approach is that my favorite will be CM. My favorite will be CM. It is my non-system approach. But if my favorite will be CM, my unfavorite away from the party. There will be break in the party. There will be several break in the party. And lastly, a party will be fragmented into several subgroups. And I will be out of the scene of politics. Who is the CM? He will be out of the seat, and the whole thing will be destroyed completely. There are several political parties they have destroyed because of this, that they have the problem solving by virtue of the issue, not virtue of the system. How many will be annoyed? कितने लोग नाराज हो जाएंगे? इसका उन्होंने कभी परवाह नहीं की. So this is the non-system approach of solving the problem. But if you have the approach of problem solving using a system, then one has to calculate the positive forces, the negative forces, hidden forces, and also the future possible forces that a person will be CM if in next 5 years, the goal is a person will be CM if in next 5 years my government repeats again. This is the goal. So system solving approach is very important rather than the individual one. So suppose we have a system, then university has a system. It has a central office, it has a library, it has a department, then sports ground, faculties, campus residence, laboratories, hostels, and many other things are there. So that constitute a university, and university is a system. And a system runs by virtue of collective contribution by each of them. Teacher comes for teaching, students comes for learning, then employees, they are supporting the system, sports ground are for the entertainment, and also when students enters into university system, the students become the raw material, and when students comes out, the students becomes a degree holder, and when a research scholar come out, or a scholar becomes a student becomes the scholar. Up to PG you are the student, but the moment you enter into research you are the scholar, and whenever you come out after research, the person is a doctoral degree. So the change is produced because of student passes through a university system where the central office is there, library is there, faculties are there, and laboratories are there, and hostels are there. So system needs some input and output. Then students are the input into the system. It's a continuous input appears in the university system. Student stay in the university system for 1 year or 2 years, and thereafter they pass out and new student comes. So this is a continuous process of admission and result, and some student get pass, some student gets distinction, some student gets awards, and some students becomes दो बूंद जिंदगी के, आंखों से आंसू, ये नहीं होता. So this is what the students are passing through the system. कभी आपने देखा वो गन्ने का रस, ये पता नहीं यहाँ महाराष्ट्र में मिलता है कि नहीं. महाराष्ट्र is famous for that, largest production of sugarcane. You just see there is a machine, sugarcane is here, and glasses are here. People are waiting here, not here. This is available 2 pieces in 10 rupees, and this side 20 rupees for 1 glass. And what is happening? This thing is passing through a machine, and juice is here. Juice is 20 rupees per glass, and it is 2 pieces in 10 rupees. This is what the transformation of the person. This is what the academic system. This is what the university system, where you pass through a university. Before going to university, you might have been only graduate or only 12th pass, and after the university life, you became the scholar, and you can earn 30,000-40,000 rupees if you pass through that university system. This is the system, and the system has so many variables. So, also the new faculty used to come in the university system, retirement of the faculty, that also take place. So system is a dynamic system. Students are coming, faculties are coming, activities are going on, and students are participating in those activities, getting some medals, getting some awards, mementos, and finally they are pass out, and when they come again as an alumni, they feel pleasure in the university, whether the university may be of any kind of ranking, but they feel pleasure. So if we have the system, we have the system which is a physical system. Systems are many types. Physical system, computer is there. Computer is a physical system. We can visualize the system. We can visualize this computer system. Also, the system who appears physically, like TV. TV is a system. The input is electromagnetic wave. Output is picture. Output is song. That is the output. So TV is a system, wave as an input, and output is song. Output is picture. So, and likewise, share market. It is also a system, and output is profit. Input is the investment. Investment in share market, it processes, it says ups and down, and output is the profit or maybe the loss. It depends. So it is a virtual type of system, and computer is also a kind of system we have. So these are the basically physical system. We have a biological system. Likewise, our human body consists of several components. The whole body is a system. It has a breathing system. Breathing system is nose, lung. This is the part of breathing system. We also have a digestive system, that is our liver, and also the intestine. And we also have a reproductive system. We also have a heart as a system which pumps throughout the life, and also eyes, hearing. These are the sensors. So with all these constitute a system. So there in every system there are subsystems. This camera is also a system, and it also has several subsystem like input unit, output unit, recording unit, storage unit, and so on. So every system has a subsystem. Then subsystem may have another subsystem. So these subsystems, if we study, we find that there are a number of variables they are affecting the system. We also some other example of this, that is the economic system, factory or industry, that is also a system. Then business system, then we have a social system, then we have a political system, and we have a treatment system. A doctor says that you take this medicine for 1 week, then take these are the medicine for next week, then take these are the medicine for next week. Means doctor also provides a kind of treatment system where medicines are there, advices are there, exercises are there, then test procedures are there, and also the feedback is there. And political system, we are always aware of. In political system, there is no mathematics. In inaugural session, there was a unique words, that is 1 plus 1 is equal to 2 is the simplest relation. It is the simplest mathematical relation. But if you move to the political system, there is a 1 plus 1 is 2, not sure. A party A, if has alliance with party B, both vanishes. It happens. And sometimes if party A has alliance with party B, both improves. And sometimes a party A has alliance with party B, A improves drastically and B loses, because vote doesn't transfer. The core vote, every party has a core vote and volatile vote. Volatile voters, they are hidden voters, and dedicated voters are those who will vote for that party. So the transfer of vote, while 1 plus 1 doesn't make 2, then it may have 0, it may have 0, 1, or it may have 0, 0. So this is the political system, there is no mathematics. Sometimes in chemistry there is no mathematics. Say for example, if you increase the one chemical with another chemical, there is a production of the third chemical, and if you increase double, there may production triple, and if you increase further, there may blast. If one chemical is very high, in other chemical is also very high, at low level they produce double, at medium level both produces 4 times, but if you have the high level of mixture, there will be blast, and the experimental, the person who is doing experiment will go to the doctor. This is, so 1 plus 1, 2, or 2 plus 2, 4 only happens in mathematics. There is nothing sure in chemistry and nothing sure in political system. So we have system, every system has a forces. There are lots of forces that system has. System is structurally divided into the different kind of functionality. A system also has various kinds of variables they are affecting to the system. Say for example, our body is a system and we are sitting here. Some outer forces, that is heat, air, and also the breathing of others, and also the some noises of others, that also affects ourselves. So external, there are several variables, they affect the system, and therefore whenever a problem needs to be solved, a problem needs to be solved in terms of the entire system rather than a particular problem. Say if doctor, several people, particularly the Ayurvedic people, who have a kind of treatment system, treatment for the human body, they claims that we treat the whole body, whereas the allopathic people, I'm not sure, this is not my word, allopathic people, allopathic way of treatment is goal oriented. If running nose, take this medicine. If swelling in throat, take this medicine. And if digestion is poor, take this medicine. But whole body is a system. If I take the medicine for digestion, there may breathing problem appear. And if we take the breathing problem treatment, then my digestion will be abnormal. Or so the system approach of solving the problem is sometimes may not be in the therapy of one kind, and it may be present in the therapy of other kind. So that is why we have to be with the system approach. The characteristics of the system is, say for example, postal system. So system has entities, attributes, interrelationship, dependencies, parameters, etc. And these things needs to be studied. Whenever we model the situation, we must have to understand what is the system. Say for example, postal system. Postal system means there is a post office, there is a queue of person, and a person is coming to the queue, and there is a service provider, one counter is providing the service, and person is going out. So queue is creating, person is going out. So there may be the average time of waiting. How much time, if a person arrived, how much time waiting is there? This is it's a kind of parameter which is unknown, and it depends on morning time different, daytime different, evening time different, and closing time it may blast also. So several, and also computer, it has attributes like speed, capabilities, and activities, input, output. These are the attributes for the system, and whenever we come for the learning the system, before modeling, we need to study the component of the system, entities of the system, and also the attribute of the system. System we can classify as the natural system, like solar system, it's a natural system. Artificial system, that is computer, which is an artificial system. Stable system, and also the unstable system. So share market is a kind of unstable system. You don't know tomorrow will be Sensex will be up or Sensex will be down, but there may be a stable system, like a company is producing car is producing every day, producing 300 cars, so every day they are producing 300 cars. Sometimes it is 280, sometimes it is 310, but it's kind of a stable system of the production of the car. Whereas the unstable system, we cannot predict how much share price will jump today, tomorrow, or day after tomorrow. So there is a static type of system, that is the crop production system. Crop production system is a kind of static system where we have say crop production of wheat every year in India, this much amount, crop production of rice every year in India, this much of amount, or production of gram in any region is of this amount. Every year either there will be slight increase or a slight decrease, and also sometimes due to unavoidable reasons like flood or maybe tufan, that there may a kind of variation. So this static system changes, and also the dynamic system which changes over time. Changes over time means time, it depends on time. For example, GST collection. GST collection is a system and it changes. Every month you have the different amount of GST collection. Sometimes it is 1 lakh in a month, and next month it will be 1.6 lakh, another month it will be 1.2 lakh. So it is a kind of time dependent system. How much GST will be collected is difficult to predict. And dynamic system is basically it is predictable, like electric fan. It is a dynamic system. You can improve the input, and there will be speed of the fan will improve or increase accordingly. So this is a deterministic system. It is predictable. At TV, it is predictable. If you have larger volume, then sound will be high. If you have a smaller choice, then it will be low. Fridge you can also control. So it is a deterministic system. For every given input, there will be an output. And non-deterministic system, they are basically the stochastic system, and where, say for example, weather system. Weather system is a system which is unpredictable. When there will be rain, when there will be fog, it is difficult to predict. However, up to some level we can predict, but it is non-deterministic, or we can say stochastic system. And also the adaptive system. Say for example, our body is a kind of adaptive system. If we have, if in winter season our skin becomes something different, in summer season our skin becomes something like at different level. And also, say for example, some of the animals, if they have the adaptive system, if there is a rainfall, they move somewhere else. If there is a ice, then they escape from their original position and they move somewhere else. So the animal body is a kind of adaptive system which is adaptive with respect to the environment. And also some systems are the linear systems, like insurance policy. It is a kind of linear kind of, every month you pay and your amount profit will be accumulated in your account. A regular kind of profit will be, or you can have the banking fixed deposit. There will be a kind of linear growth on your amount, whatever is deposited. So there is a state of the system which consisting of the endogenous activities and exogenous activities. So endogenous activities, basically they are inside the system, whereas the exogenous activities, they are outside the system. Say we are affected by two things. Our inner body, say if our body is not digesting the food, it is our endogenous activities. Due to inner forces, our body is not digesting a particular meal, whereas body external forces are there. Say for example, it's very hot. If it's very hot, we avoid tea rather than we like to have cold drink. So because external force is there which is affecting our body as a system. So there are always, if our body is a system, then endogenous sources and factors are there, and exogenous factors are also there. And also there is a system boundaries and system environment. Every system, it has a boundaries, it has an environment. Say for example, if there is a medicine, then it is advised that you keep the medicine in cool and dry place. Cool and dry place. So that is the environment in which you have to keep the medicine. Whereas the boundaries are there. That is, in a fridge, you have a boundary. That is, for this medicine, not much cold is required. For this medicine, acute cold is required. So you can put the medicine in the deep freezer. You can put the medicine in the normal part of the freezer. So for every system, there is a boundary, there is an environment, and there are variables affecting from outside also. They outside variables, they affect the environment and they affect to the system. Now, modeling. I am walking like this and move here and move here and going this. It is the modeling. We see in TV, this is the modeling. But this coat is not suitable for modeling. It should be something like touching to the ground. That is modeling. Okay? If my coat is touching to the ground and my tie is not this, it is very thin, only half centimeter, and coat is touching to the ground, it is modeling. I will move from here to there and it will come back. This be general assumption of the model that we have. And for this workshop, this is not the modeling. This is not the modeling. And before modeling, we must understand the system, because we model the variables of the system. So first part was the system, understanding of the system and knowledge of the system. Then if we come for the modeling in terms of mathematics, then we have model is actually a representative of the truth. It is an abstraction of the real situation. Say for example, for real situation is aircraft. Rafale is the real situation. And we have a Rafale in 2 feet size. This is the model. This is the model which is representing the Rafale. Ram Lala Mandir. Model. Huge sailing is there outside in the market for all those who are selling the temple. And it is of size 2 feet by 2 feet. It is a model. It is a model. So it is why model? It is a representation of truth. It is a representation of the reality. So that is a model. And it is simplified representation of a system. When we come for modeling of mathematical utilization, it is always need a system. If there exists a system, then only we can model, otherwise not. There is no mathematical modeling exists if we do not have the system. So system comes first, modeling comes second, and solution using system approach is simulation. Simulation is the actually analysis and final output. So if we have the model, it is simplified and it helps us to control the system. Why to control the system? a good leader is, who is a good leader? Who controls the whole political system is a good leader. I am not a good leader. I am not a good head of the department. Why? Because several faculties in my department, they do not obey me. I say, if you arrange this activity, I have no time. I am writing a research paper. I am writing a project, sir. I am not available. So, I am a good academician, I am a good teacher, I am a good researcher, but I am not a good leader. Okay, I am not a good leader. Why? Because in the system, which is a university system, department is a sub-component of the university system, and I am not able to get problems solved in a system approach. However, I can solve a problem in a pointed approach or a particular approach. I have arranged this activity of 22nd December, Ramanujam Day on 22nd, and most of the work I did my own level, right from first activity to end activity. It was not a system solving. All have participated, all came, all appeared, they have participated, but while preparation and organization, I myself put my personal effort. So this makes problem solving approach not system based. It is the problem solving approach on issue based, on point based. On that particular problem I solved, but for the whole system the problem is not solved. So it helps to control the system if a model is effective. Also it helps to predict about the system in future. Say, one prediction, very popular in TV, Viksit Bharat 47. Viksit Bharat 47. How it is possible? The whole country is a system. There are several forces positive, there are several forces negative. 140 crore peoples are there. It is possible if all will contribute. It is all will contribute. Then only farmer will do their role, academician will do their role, the businessmen will perform their role. All will attach as a component in the whole system. Then only we can achieve a goal. So this is a system approach of obtaining the objective in 2047. We will be Viksit Bharat. Nowadays we are Vikasil Bharat. We are developing country. We are not a developed country. So if I only work, or all those who are sitting in this room, they work, we cannot achieve the level of Viksit Bharat. So for this we have to think for system modeling and system approach for achieving the goal. So this is where the model is required. And if Viksit Bharat model is there, then we have to think, can we develop a mathematical model right now for Viksit Bharat? क्या अभी हम सोचे कि हम विकसित भारत का मॉडल करें? तो सबसे पहले सिस्टम क्या है? टैक्स सिस्टम को इम्प्रूव करना. ये पैसा नहीं होगा तो काहे का विकास? अगर हमको इस कोर्ट का विकास करना होगा पैसा चाहिए, पहलवान बनना होगा, शरीर का विकास करना पैसा चाहिए. So first we have to improve our tax system. First we have to improve the economy. Everyone should be involved in economy. Government job is not the economy. Government job, some private job, lots of startup. Then instead of purchaser, we have to be supplier. Instead of purchasing defense items, we should be the supplier of the defense products. We should be the supplier of the agricultural products. But unfortunately, our population grows so fast. Our agriculture growth that consumes in the population. So we cannot be a very good supplier, but we can be a good supplier of defense article. We can be a good supplier of chip. Chip means not Uncle Chips. It is not Uncle Chip, it is chip. Okay. If we are powerful, if we are having a powerful hub of chip making around the world, then we have lots of orders that you design this kind of chip for us. Taiwan, see Taiwan. Taiwan is a very small country, but have the immense amount of potential of developing chips ruling in the entire world. So if we have this kind of thing, we will be the producer of chip rather than purchaser. So model is become producer, supplier rather than purchaser. Trading should be minimized and supply should be maximized. This is the model. This is the base. So the whole system we have to convert. At present, 10-15 years back, we were having very good traders from other countries. Chinese mal, Chinese jhalar, Chinese coat. Chinese means general opinion, general model for Chinese is what? Chinese के विषय में general model है, वो ये है कि item is good, life is less. Item is good, life is less. This is the model assumption for Chinese item. And cost is also low. Cost is also item fancy, cost low, and life is less. If we revert this thing and we become the supplier through system approach, we will be earning money, and if earning, then by virtue of earning money, the infrastructure will be there, and by virtue of infrastructure, we can create a better life, and we can invest those money in scientific development, and by virtue of the scientific development, we will grow. Lots of technologies we will grow, and we will supply technologies to others. In this way, we can say that we will be modeling for Viksit Bharat. So this is what the thinking for pattern of change, modeling that we can think for change of pattern. It is an interactive process which derives power from the computational efficiency. If we focus on the mathematics, then if we identify the forces, their interrelationship of developing the whole country, and by virtue of this, we can have a decision making, a target that we can achieve this kind of target in this particular area, in this particular time, because the expectation is like this. Suppose our expectation is that we will be 5 trillion economy in 2030. So there is an economic system in the entire country. There are several variables in the entire economic system. Which variable we have to control, which variable we have to maximize, and every variable has an interrelationship among others. If you improve this, other will be down. If you improve the supply, price will be low. If you improve the price, then demand may reduce, person may shift to the other item. So every variable has interrelationship. So in this way, we have to decide the types of model that we have. One is the mental model. Mental model means personal view. What is a king? What meaning by king? What meaning by God? What is the meaning of beggar? Cook, cricketer. Personal decision making, or when to purchase and when do not purchase. This is our mental model. First, this workshop is for modeling. One modeling I have shown. I moved there and I came here. This is modeling. I can move there and I can move here. This is modeling, which we understand by modeling. But every day has the model, and every person has the model. When I was research scholar, किसी ने हमसे पूछा कैसी बीबी पसंद करते हो? It is a model. दूसरे से पूछा, he has a different model. तीसरे से पूछा, he has a no model. What mummy papa say, I agree. No model. It is a mental model. If I say that he is very good person, अक्सर आप भी कहते हो he is a very good person. If he is a very good person, it means I have a model in my mind of a good person. If he matches with that, he is a good person. Otherwise not. So we always have a model with us, like personal viewpoint. And also the decision making. If I am not capable enough to take enough risks, then I invest in bank fixed deposit. If I have capacity to take a risk, I will invest in share market. And if I have capacity to take more risk, I will invest in land purchase, because land purchase is very risky. Somebody may capture. If you are in UP or you are in Bihar, tomorrow you will see that a red flag is there on your land and somebody has occupied your land. Whole investment becomes zero. Even it is risky, more risky than the share market. Share market में तो कभी सोच लो चला गया आज, पिछले साल अडानी का चला गया था, इस साल अडानी का उठ गया, तो possible. But in land it's very risky. So decision making differs from person to person, risk depending upon the risk capacity. So when to purchase, when to invest, personal viewpoint about an object, personal about the poor. What is poor? Nothing is poor. Good. What is good? No definition of good. कोई अच्छे की कोई परिभाषा नहीं, अच्छे की कोई परिभाषा, बुरे की कोई परिभाषा नहीं. So these are the mental model. कोई किसी के लिए अच्छा तो कोई किसी के लिए बुरा. Somebody if you go to parliament, वहाँ कोई अच्छा नहीं, वहाँ कोई अच्छा नहीं. If you are in opposition, सामने वाला बुरा. If you are in the party, वो अच्छा, वो अच्छा. So what model they use? What mental model they use? So it is a volatile mental model where nothing is good and nothing is bad. Mental model is also that is writing a story. एक छोटा बच्चा कहानी लिखता है, कुछ कल्पना करता है, करते लिखता है, लिख के आपको दिखाता है. That is a his mental model. कभी कभी साइको टेस्ट होते हैं जहाँ ये कहा जाता है अब भाई इसके मन में क्या है, तो कहा बच्चे को कागज पेन दे दिया जाता है, तुम खुद कुछ लिखो, whatever you want you write, and by virtue of that one can assess the psychologists assess the mental state of the person. So that is the writing a story and writing experience. That is also a mental model. Say I visited Tamil Nadu and I wrote a kind of 100 words on WhatsApp. It's my mental model. But if my friend also was with me, his mental model was different. I appreciated in Tamil Nadu a particular park, but he told that park was as usual, very dirty. I told that park was dirty, but animals were very good. So I focused on the animal, he focused on the dirty part. So it depends. So this is experience, different experience depends upon the mental modeling of the person. Physical model, you know that there is a 3D model of a house, 3D model of a temple, 3D model of a railway bridge, maybe the 3D model of a tank. Most renowned tank nowadays is Markova tank, that is used by Israel. That is the most popular tank. So it may have a 3D model. Gun, children's toys, they are gun, they are the 3D model. These models are used in training. These models, they are used in learning. So when students come in school, the learning starts. And if after graduation, he moves to army, training starts. So training, learning, these are the parts. So in this way, we have the physical model. We have different kind of physical model. The scaled model means आपने 10 सेंटीमीटर को 1 सेंटीमीटर, 10 मीटर को 1 सेंटीमीटर बना के बड़ी चीज को छोटा कर दिया. That is a static model, और उसको छोटा कर दिया. Imitation model बनाया, puppets बनाया. There is a short film program on TV, maybe appear in Aaj Tak, maybe appear in Z TV, sometime comes in other channel, in which Amit Shah appear as a puppet and moves. I hope you have seen. Oh my God, the name is Oh My God. Oh My God. So the reality is being expressed using the moving model, moving characters, Kathputli, that is a puppet. These are the models. Raja Amar Singh Rathore, Kathputli ghum rahi hai. This is this is a model, cartoon, puppets, these things are. And dynamic model, those who are moving. Say for example, a new rail engine prepared by a factory, integral coach factory, prepared a new rail engine, and the model of the rail engine is moving.
Pardon me, sir. Pardon me.
Yes.
Time constraint.
Time constraint.
Conclude this event.
Conclude. I hope मैं तो इतना अच्छा नाश्ता करके आया था कि मैं 1 घंटे से और चल सकता. I hope you have not taken your breakfast enough. Okay, I will wind up in 15 minutes. So this is what the dynamic model and analog model and also prototype. Prototype means उसका similar जैसे वो होता है उसका similar एक बना लेते हैं moving reality. And also the symbolic model. ये symbolic model है. Symbolic model means no smoking. It is a model. एक गोला बनाया काट दिया सिगरेट बनाया no smoking. Okay, U-turn, it is a symbolic model. H2O, it is a symbolic model. Okay, left turn, railway crossing, zebra crossing, these are the symbolic models. So we have symbolic religious symbols just like Om. Om is a religious symbol. It has so much meaning. So if there may be a religious symbol, there may be a traffic model, there may U-turn, parking prohibited. So this is a symbolic model. We have then comes here, and this is your workshop. Your workshop starts from here. Okay, but before workshop, there are lots of things that needs to be discussed. The first part is the system and its understanding. Second part is learning about the models, their variety of models, and otherwise what is model, you always assume what is model. But in particular, for mathematician, for this workshop, we have mathematical models. Okay, so I will focus on this part. There is a linguistic models like sutra mantra, then chemical symbols, chemical reaction model, then we have the those models who are in language form, like sutra, mantra, etc. They are the linguistic models, and we have the graphical models. So for example, drawing, painting, XY graph, then bar chart, pie chart. These are also the models, but they are the graphical models. And we have the semantic models. Semantic models means roadmap, layout of a project. Roadmap means at this time we will finish this, that at this time we will finish this, at this time we will complete the whole project. Flow chart, I hope you computer people know the flow chart. There may be a circuit diagram. In physics there is a circuit diagram like capacitor, condenser, then resistance. They are attached each other to form a goal, to achieve a goal. So this is the semantic model and mathematical model. Very dangerous, very dangerous. And for this danger, you are here. Okay, and you are listening me. And for danger, I am wearing the coat. Because danger is there. Danger is there. Danger is in mathematical model. What is mathematical model? It is basically, it is a set of mathematical and logical relation among the system elements. So system, if there is no system, you cannot say there is a model. There must be a system. And system, it has elements, it has variables. And system, it has a component. Say our body has a digestive system, our body has a respiratory system, and every system connects with each other, it has a variables, and then differential equation is used to represent a system. Mathematical modeling starts from here. Differential equation. Differential equation. Say, for example, if I give you 2 rupees, you will give me 4 rupees. If I will give you 4 rupees, you give me 6 rupees. If I give you 6 rupees, you give me 8 rupees. And it continues. So, this is happening in a system of a classroom where my lecture is going on and 2 persons are exchanging the money. There is a mathematics involved behind this. इसके पीछे गणित है. ऐसा होता है. कब होता है? जब दामाद 10 रुपए देता है तो ससुर 15 रुपए देता है. और दामाद 15 देता है तो ससुर 20 रुपए देता है. ससुर, I know you. It happens. It happens in our Indian system. Behind this there is a mathematics. Mathematics क्या है कि ससुर is x variable and दामाद is y variable and x is greater than y, and also y is equal to x plus a, where a is 5 rupees. If he gives 10, he gets return 15. If he gets 15, he gets 20. The relationship is y is equal to x plus a. Y is equal to x plus a. And the relation is dy by dx is equal to constant. Dy by dx is, if you differentiate a line, you will get a constant. So dy by dx is equal to 1. Dy by dx is equal to 1 for this. So I fit a mathematics in a social phenomena where something has happened. And there is a relationship. Why relationship? कि आपका पैसा हमें नहीं रखना. This is the theme. आप जितना देंगे हम उसका ज़्यादा देंगे. So this is the theme. And this theme is modeled by a linear relationship. अब इसके बाद कहीं कुछ और हो रहा है. वो एक ताश का गेम होता है. मैंने कहा लगाया, उन्होंने दुगना लगाया, हमने कहा और लगाया, उन्होंने और लगाया, हमने कहा और लगाया, उन्होंने और लगाया. डबल ट्रिपल होता है, कोई ताश का गेम होता है ऐसा. I hope those who are player, they might be knowing it. That होता है ऐसा डबल लगाने वाला, और फिर उसका 4 गुना लगा के शो कराते हैं.
So please.
Yeah, I'm binding up. So this happens. It means there is a mathematics. There is mathematics is y is equal to x square. Whatever x takes value, y becomes double. 4 times, 6 times, 8 times, and dy by dx is x. dy by dx is x. This is the modeling for that phenomenon. Okay, for only exchange of money. Then there might be several variables affecting that game playing, and all can be modeled by the mathematics. So this is what we talk about, and there are a number of types of models. We have the static model, dynamic model, numerical model. This is very interesting. This is very interesting. A numerical model. A is greater than 10, B is greater than take decision 1. Decision 1 means someday A greater than 1, A greater than this, B greater than this, I will do this. And if A is less than 10, B is greater than this, follow the decision 2. Decision 2. Say train, बहुत सारी ट्रेन है, ट्रेन लेट है. If this train arrives, वो ट्रेन वहाँ जाती है, तो मैं बस से चला जाऊँगा. If this train arrive at this station, this train becomes late, then I will pick up this train. So in this way, this is numerical modeling. This is numerical modeling. dy by dx is one modeling. This is a numerical modeling. And doctor's decision is also a model, that if your fever is 104, take this set of medicine. If it is 102, take this set of medicine. If it is 100, take this medicine. So doctor's decision is also depending upon the temperature and body movement. If you are feeling good, your body movement improves, then take this medicine. So this is the numerical models. This is the numerical model. And this is the mathematical model. In all other lectures, if you follow or if you go to the book of mathematical modeling, it starts from here. It starts from here. That is, m is a factor, dy by dt, then nt, then ft. dy by dt, then pt minus a. This is the mathematical modeling. This is the base of the mathematical modeling. But behind any kind of modeling, first comes the system, study of the system. Then system variables, relationship between system variables. And then examine the changes happening by changing of in one variable with the other variable. And then set dy by dt means rate of change with respect to time. Okay, rate of change, and then you can fit the model. This kind of model, these are the dynamic model because they are depending upon time. And we have the simulation model. Simulation models is basically based on numeric data, numeric picture, and after numeric picture, we get, say for example, this is one interesting example where simulation model works. A train arrives at a station. आप देखिए ट्रेन स्टेशन, कोई भी ट्रेन पूरे 30 दिन सही समय पे नहीं आती. Sometimes it is 5 minutes late, sometimes it is 10 minutes late, sometimes it is 15 minutes late, and sometimes it is 10 hours late. Okay? Then अगर ट्रेन यहाँ लेट है तो एक ऐप है, Where is my train? I hope you might be knowing, Where is my train? तो आपको बता देगी उस जगह पे ये ट्रेन ये टाइम पे आएगी. So whenever train is late, then you can develop a kind of model, simulation model, and you can find at what time the train arrives at railway station, when it is usually runs late, at what time it will arrive, what is the average time of arriving of this train in this station of Nagpur, when it is usually late, sometimes 5 minutes, sometimes 10 minutes, sometimes half an hour, and also the data of the past 10 railway stations of arrival is also available. On the basis of that, you can make a kind of simulation exercise that what is the average amount of arrival time at the railway station. So there are several deterministic mathematical models. We have the stochastic mathematical model. These are the models I hope the other lecture will take into consideration. And we have the stochastic models, we have the biological model, agricultural model, forecasting model, and financial prediction model. These financial prediction, if India reaching to the 5 trillion stage in 2030, it is the financial prediction model which helps to predict that we can reach it at the 5 trillion economy by 2030. And we have electrical model, population model. We already have after 10 years what will be our population. This is population projection, and also wages and salary model. This is very important. Government has made a fitment factor. I hope somewhat fitment factor. Fitment factor means if the is up to this level, then the whole restructuring that is start. That is also a kind of mathematical model, and it provides you the wages and salary, how much a central government needs to pay. And there are other type of models, software testing model, reliability models, banking models, life prediction model, because life prediction models are important for those who are getting the paying the premium to the insurance sector. So insurance sector has always a kind of life prediction, and that by virtue of which the premium is being decided, and then modeling methodology is effective when mature. For modeling, one thing is there, that some mature theory should be available. Some mature theory should be, say for example, if I have to model for this classroom, I cannot do model. First I have to study the system, then I have to collect the data, and then on the basis of the data we have to make analysis of the system, and then we can model. So a mature amount of theory is required, and also the interrelationship that also needs to be studied. And we have several modeling methodologies, drawing a subset of variables in the system, develop interrelationship. Modeling is a skill based on expertise, intuition, judgment, foresight, and system study and system analysis is very important for any modeling, in particular the mathematical modeling. One example of biological modeling, by virtue of this I hope I will wind up. X is blood flow, Y is blood density, Z1 is cholesterol level, Z2 is sugar level, blood pressure, exercise and yoga, food intake. This we do every day. It is a part of our life. But these are related. Say for example, if blood density is high, blood flow will be reduced. Okay? If sugar level is high, blood flow may differ. If cholesterol is high, blood flow may differ. And also if we take the unbalanced food input, that affects also the blood flow. So can we model the blood flow if the variables are, blood flow model is X, variables are Y, Z1, Z2, Z2. So these variables are interrelated, and we can study, we can develop a mathematical model using the blood flow system. And this is simulation is methodology which obtain the approximate solution. One solution is the exact solution, which is often not possible in mathematics, and so we have the simulation which is used to solve that model that we have developed. And last, most important is thank you. This is most interesting PowerPoint slide is thank you. Okay, so that's from my side. Anchor, please. Yes, please. Now it's yours too.
Actually, the lack of time we cannot give much more time to you. So we are our side. Sorry for that.
Okay.
Thank you, sir.
Okay.
On behalf of Postgraduate Teaching Department of Mathematics at Inauguration University, I am here for the vote of thanks for this special talk by Dr. Divakar Shukla sir. We, on behalf of department, required apology from the Shukla sir because many students had just involved in your lecture, but we just cut off your lecture due to the time constraint. Really sorry, sir. And on behalf of Department of Mathematics, I am thankful Dr. Divakar Shukla sir for their lecture on the basis of system modeling and simulation. It is very interesting, sir, and my dear students are involved very much on that, and mathematical modeling is one of the subject in the postgraduate department, so might be it provide a basis for them. So really thankful for your insights, sir. On behalf of president of our program, I declare that this talk has been ended here, and after this one online lecture is going on, and after that refreshment will be given to the students. So please wait for 5 minutes. We will connect to the online meeting for the second talk. Thank you.
So shall I share my screen? Yeah, very much. Absolutely. Hello.
Yes, sir. Good afternoon, everyone. We are privileged to welcome another guest of honor, Honorable Dr. G.P. Rajashekar, sir, Professor, Department of Mathematics, Indian Institute of Technology, Kharagpur. He has his expertise in partial differential equation theory and its applications, fluid mechanics, boundary integral methods. He is currently working as professor on HEG scale, Department of Mathematics, IIT Kharagpur, since August 2019. He is awarded with many fellowships, Mathematician of the Year Award in 2018, Royal Society Award, and many more. I heartily welcome you, sir. I request Honorable Dr. G.P. Rajashekar, sir, to guide us on the basis of mathematical modeling to real-life applications.
Thank you very much for your kind introduction. Hope I am audible to you all.
Yes, sir.
Am I audible? Okay, so the slides are moving. Confirm, slides are moving. Yes, yes. Okay. So first of all, let me take this opportunity to thank Professor Ganesh Kedar for the opportunity inviting me to this workshop. And I never visited Nagpur University, but have a longer association. Professor Deshmukh also is a regular member of ISTAM. He used to visit our annual ISTAM meetings along with Professor Ganesh Kedar. So since the workshop is on mathematical modeling, I thought, of course, by now we would have heard from other colleagues, but I try to keep something slightly different. So I'll cover some basics. Then in particular, I focus on German modeling. Okay. So what what is typically mathematical modeling? It is nothing but whatever physical phenomena we see, we observe, with some perception, we translate it using the language of mathematics. Okay. So in this process, certainly we need some assumptions. Because without assumptions, so once you have some assumptions, we limit the model. And also we need the knowledge, current knowledge of the system which we are trying to model. And then we try to consider some effects, external effects, internal effects, etc. Okay. So for example, you can see the auditorium where you are sitting. You have some chairs. Middle there is a welcome area. Suppose you have fixed with only one small air conditioner, and then hot summer, outside temperature 52 degrees, and inside you have just one small AC. Then the middle portion is also filled with a lot of chairs. So definitely you won't be able to sit there. So that means what is the height, width of the room, then what is the heat transfer model, whether it is a steady state heat conduction or unsteady state heat conduction. So these are the things we have to. And one more information is the boundaries, that means the walls of the auditorium. Suppose one wall is completely is frozen from outside, or one wall is a lot of heat supplied. So then you have your modeling assumption will go wrong. So these are the assumptions you should know when you are trying to model. So what are these? Outcome based. That means if I measure something, I know what is it. So that's an outcome, right? So deterministic and stochastic. So deterministic means you do this, then we get it. And we have to use this model only. Suppose you are, again, and come back to steady heat conduction. I hope the students have done first course of PDE. Then steady heat conduction is simply Laplace equation, right? Okay. I think, sorry, if I am physically, if I can just do it, then sorry for this. Sir, Dr. Namnik is going to ask something. Please. Yeah.
Yeah, right. Thank you so much for such a wonderful lecture. Actually, I want to know that in some of the cases there is no experimental study available. Then how can we justify with our obtained result? How we can check that the results are suitable or not, sir?
Yeah. So there, first thing you have to do is, if it is a time-dependent system, you could take a steady state and you calculate steady state solution and keep it separately. Then you solve the time-dependent system and take t goes to infinity large time scale, whether your large time scale solution is matching with the steady state solution. This is one check. Another check is you take a small perturbation of the system and see the difference between no perturbation and small perturbation. If this difference is quite large, there is something wrong with the system. The third one is always do not take data from anywhere left and right or as per our assumption. We try to take data from literature which are close to real data. That means, suppose somebody is modeling fluid mechanics, flow models, etc., fluid, then porous media, etc., you should always look for the permeability range. Which one? Are you talking about the synthetic sponge of this thing, or are you talking about gravel? Are you talking about silica? What is the permeability? Then fluid, what type of fluids you are talking? What are the viscosity ranges? So, if we know this data, at least whatever result we generate, we write it in the caption that these are the data for this fluid, this character of the material, Therefore, these results are more appropriate to such systems. So these are the combinations: stability check, steady state check, parameter ranges. This we have to always keep.
Thank you, sir. Any more questions, please?
From audience? Any questions?
Okay. So, anyway, it was really very nice lecture. And Professor, you must be here next time in
My sister apologies, I could not come, but I will be there next time.
your lecture was really very nice, and all the students enjoyed it. But you must be physically here next time. I invite you in advance.
Looking forward, yes.
Over to you, Shruti.
Am I audible, sir?
Yes, Shruti.
Thank you so much, Honorable Dr. G.P. Rajashekar, sir, on acknowledging us on this topic, basis of mathematical modeling to real-life applications. Am I audible, sir?
Yeah, very much.
Thank you so much, Honorable Dr. G.P. Rajashekar, sir, on acknowledging us on the topic, basis of mathematical modeling to real-life applications. We are privileged to listen you, sir. The knowledge you gave was very informative and useful for all of us. The way you explained the different models like dynamic growth models, exponential model, by taking number of examples was very effective. Thank you so much, sir, for your valuable time. Thank you, sir.
Okay.
Thank you very much for your associations. Thank you.
Okay. So I'm going to close this meeting now.
Yeah, thank you, and I'm sorry that once again I could not be there, and I promise I'll be there in future.
Yeah. Okay. Thank you.